Um, Hi, I'm Vinay, and I'm going to be talking to you about basic web development in Clojure. So we'll be talking about the basics of Clojure first as a language, because I know it's new to many of you. And then we'll move on to the basics of a backend. If you guys don't have experience with making a backend, this might be useful. And then we'll talk a little bit about making a simple app, a simple contact list. So let's talk about Clojure. So it's an awesome language. A few features of it. It's a dialect of a Lisp language, which means that it has a very unique syntax. It's also based on a Java virtual machine, which is a very useful attribute because you can use it in existing Java code bases easily, and you can also integrate Java libraries into a Clojure app. Lastly, it also has a strong emphasis on functional programming. An important feature of this is the immutable state. So, well, the lack of state, because you have immutable variables, so they can't change values, and it's a lot easier to reason about big projects as a result. So you can easily get started with Clojure development on your own computer using Leiningen, which is basically the de facto build tool for Clojure. It handles compiling, making new projects, handling tests, all kinds of stuff. And basically it's a comprehensive build tool. But today we'll be sticking with deploying an app online using the Heroku platform as a service, which is basically a way to have your app online, essentially, to access it. So some basics of Clojure as a language. So variables, as I stated before, are immutable. And this basically means that once you set a value to a variable, you can't change it. So, for example, in this case, I have a variable called my_name, which I assign the value Vinay to. And Vinay is a string, and essentially it's assigned using the def keyword, which sets it. So Clojure also embodies the idea of code as data. And what this means is that you can assign a function to a value. You can look at it as data, essentially. So in this bottom example, you make a function which takes in a value x, and it yields the sum of 5 and x. And that whole function is assigned to my function. So this is similar to languages like JavaScript, for example. We can also simplify that by using the defn macro, which basically uses function definitions by just allowing you to type in the function name, function parameters, and function implementation. So this is the same thing with that. And you can call a function, making a new expression with the function name and the argument to the function. So in this case, 5 plus 4 is 9. So you may have noticed the unique syntax in Clojure, and basically everything is comprised of S expressions, which is a way to easily reason about the function composition that's essential to Clojure. So in this case, we have an example, and this is basically a diagram of that example. You can see that it's basically a cascading structure in which you can access the results of other functions easily. So with this syntax of parentheses, for example, you can easily evaluate order of operations. So in this case, you can easily evaluate things from the inside out. It's not ambiguous at all, like many other languages. So let's talk a little bit about the basics of a web backend. So it's basically a process that is on a server that's hidden from view and handles data input and output and collection. So it can be used to get and send data to a client, which can be a web app, a mobile app, so on. And it allows for everything to stay in sync because the clients only need to handle the interface, and they can leave the application logic, for the most part, up to a backend. So we'll be making a simple contact list that basically just allows for adding contacts by name and email to a database, and then listing out contacts in the database. So the main tool we'll be using is called Composure, which is a common library in Clojure for web development. And we'll also be using a PostgreSQL database to hold the data on each contact. Okay, so we'll go over all the code, and then we can. Okay, so let's look at a database.clj file, which is one of the source files in the app. So this file I made to essentially define all of the database-related functions. So in this case, it gets the contacts and it adds a contact. So I have the get contact function laid out here, and you can look at the implementation. So the function is called get contacts, and in this case we use a database interface that we've included in, and a query function that operates upon the database defined in this variable, and it executes this query, which in this case, if you haven't used SQL before, essentially selects all of the columns from the contacts table because we want the name and the email and, in this case, a timestamp. So we can also look at the add item function, which in this case takes an item, obviously, that you want to add, and it will use a insert function, and it operates upon the same database, PostgreSDB in this case. It adds things to the contacts table, and you essentially give it a map of the columns and the values you want to add to that column. So in this case, to the name column, name is a keyword in this case in this map, you assign the value, and the value in this case is the name keyword inside the item map that's passed to it. So you can see in this example at the bottom, if you use the name, if you call the name function on a map, it will get you the value that's assigned to name. So in this case, name with the map as an argument gets the string John. So we want the name and the email to add them into the database, basically. So we can look at the basic routes that are defined in the core.clj file. There's only 2 of them in this case. And so let's first go over the 2 routes that we want to define. So we define the name of the app, so contacts app, and then the 2 routes. So we have a get and a post. The get allows us to get data from the backend, and the post allows us to send data and usually have it added to something. So in this case, we want to get contact, so that's the path, and we can post contacts. And then the post also takes the request parameter because we want to actually get the data to add. So we can add a contact. That's just pseudocode that's on this slide. So this is the function implementation for those 2 routes. So we have a get contact function. This get contact function will essentially return a map with a status of 200, which is a success code, and a body. And the body in this case is using the get items function we talked about before. So this basically gives you all of the items. Not too complicated. So the post path then takes in a request, and you can see in this part, it gets the body out of the request and then adds that item. So it uses the add item function to add the body of the request that we sent, to add that contact. The post can also be handled this way. We're using what's called a threading macro in Clojure. And basically what this does is makes a sometimes easier to look at way of identifying a function if you have a lot of composable functions inside. So in this case, you can think about it like so it takes the request, it feeds that into the body function, and then that'll get the body out of the request, and then the database add item function gets the result of that, which is the body, which is what we need. So we can look at the main functions here in the core.clj file. And in this case, we have 2 functions. One is a main function, which actually starts up the process, and one is a handler function that handles a bunch of middleware. And middleware is basically a way to, in this case, handle JSON input and output to convert Clojure maps to JSON data. And JSON data is a easy-to-use object notation for the web. So we have a handler function that takes in the contacts app that we defined before. It adds a access headers function around that, and then a JSON body function, and then a JSON response function. And that's basically what I defined. So it allows for automatically converting input and output to JSON. The main function then just uses the database create table function, which I didn't talk much about, but basically it just makes a table if you don't have one defined, so that you have a place to put data in. The print function just tells you that the compilation finished essentially and that the server is up and ready to go. And then a function that actually begins the process. So in this case, it just takes the handler defined up here and the port that you want to run it on, which it gets from an environment variable. So JSON is basically an object notation that is very common. So if you haven't used it before, basically it looks like this. So in this case, we have an ID key assigned to a 1, a name assigned to a string, and then you can have lists of data, so tags assigned to multiple values. So let's go to this page, and I'll kind of show you the finished product. So if we go to this contacts backend CLJ page on my GitHub account, you can click a deploy. Okay, so basically what that does is opens up that GitHub code in a new Heroku app that you can make on your account. So in this case, let me title this app like contacts CLJ test, just something to use it. And then you can see that it automatically makes a database in this case. So we'll deploy this, and basically what this will do is upload the code to Heroku, which will then compile it, download all of the dependencies that we included, and start it up. So it's doing that, basically. Should take about a minute. Yeah, so it's downloading stuff. And this is basically, if you used Linigan on your computer or laptop or something, this is basically what you would see. So it compiles, which with Clojure can take a while, but yeah, so you can see it's launching, and then soon enough. So while that's going, let me show you one that, or actually let me just wait. Yeah. So if you wanted to also have a local copy of this, you would need, like I mentioned before, Linigan or something to compile the code, and then like a Postgres database client, so that you can actually launch the database locally and then collect data and stuff. So this basically manages that all for you, so it definitely helps. Okay, so it's successfully deployed. Let me... So you can check the logs of the app using the Heroku toolkit, which is very helpful because it automatically lets you push to Heroku and then also lets you view the status. So in this case, it should be good to go. So let me open up a quick test front end I made. So we'll change the app name. As you can see, this is basically just the path to the API. So it includes the app name.herokuapp.com/contact, which is the path we defined. So we can add a name. I don't know. That wasn't. So some email. And if we click add, as you can see, it's basically successfully. Oh God. So as you can see, if I do this again, you can see the GET request, which in this case went to the backend and then added a contact. And then if you want to update the view, it sends a, sorry, that was the GET. And then if you want to update the view, it gets a GET request. And if you want to add something, you can see it sends the POST, and then the GET to get the updated data. Yeah, so I hope this basically helped help you with a general high-level overview of a backend, how to deploy one, how to make one. So if you have any questions, you can definitely come up to me or anyone else. I'll be happy to help. But yeah, thank you for your time.